Hi everyone, welcome back. So today we are going to continue to talk about discrete time Markov chain. And today I'm going to give you some in-class exercise problem, but before we do that, I'm going to refresh your memory. So I'm going to use the same handout that I've used last time. So last time we talked about the first passage time, right? That is the represented by capital N sub ij, and that represents the number of transitions made in going from state number I to state number j for the very first time. Okay, here the keyword is the first. So keep in mind that the first passage time is the number of transitions made that the process is going from state I to state j for the very first time. And we also talked about first passage probabilities or first visit probabilities. Okay, there is the probability that the process starting from state I and will first reach state j, okay, or visit state j in exactly n steps, in exactly n transitions. Okay, so record that P sub ij, there is an n-step transition probability. State that there is the probability starting in state I, and then you end up with in state j after n transitions, n steps, but perhaps not for the very first visit. Okay, so that's the main differences. And last time we used the weather forecast example to distinguish this n-step first passage probability f sub ij from n-step transition probability p sub ij, right? Thank you. I'm going to give it to you later. Okay, not right now. So for the 2-day forecast example, using the same summer weather example, here's the main differences, right? So P sub 1,3 in square matrix, in words, it is a probability that the weather will be cool on Friday given the weather is hot on Wednesday. And we also talked about the first passage probability, f sub 1,3. That is the probability that the weather will be cool on Friday for the very first time, given the weather will be hot on Wednesday, right? So here the main differences is you need to take out this portion to make sure the weather on Friday will be cool for the very first time. Because in that case, weather on Thursday was cool already, right? That's why we need to take out this whole part, okay? And last time I also showed you how we come up with this n-step first passage probability, right? And we need to obtain the first passage probability, we need to do what is called recursive computation. And I showed you how to do it using an example problem, right? And we also talked about mean first passage time is represented by m sub ij. It is the expected number of stages. It is the number of expected number of transitions at which the system, the process, starting in state I, and then first reaches state j. Okay. And last time I showed you how to use both of these formula using an example. So when you consider the mean first passage time, let's say m sub ij, if the subscript I is equal to j, then this first passage time is the number of transitions until the process returns to the initial state I. And I mentioned in this case, the first passage time is called the recurrence time for the initial state I, right? And it can be obtained by, if you take the reciprocal of steady state probability, pi I, okay? So that's what we talked about last time. Okay, now let me give you an example in-class exercise problem that we are going to solve together. I'm going to give it to you. Okay. Okay. Okay, so let me, so while I'm adjusting this Word documentation, why don't you take some time to read through the problem description, okay? I'm going to get back to you very soon. Okay, let me adjust the size as well.
Dr. Swan?
Yes.
There's a positive and negative number left or the right corner. You can make it bigger if that's what you're looking for.
Positive and negative on the left?
Bottom right corner.
Bottom right corner? Oh, okay.
Yeah, and that makes it smaller.
Oh, yeah, that's right. Okay. Thank you. That's true, right. Okay, I made this using other programs, so. Okay, I think that'll be fine. Okay, now let's work on it together. So first, let me read through the problem description. Okay, so the city's water supply comes from a reservoir, and careful study of this reservoir over the past 20 years has shown that if the reservoir was full at the beginning of one summer, then the probability that it would be full at the beginning of the next summer is 80%. However, if the reservoir was not full at the beginning of one summer, the probability that it would be full at the beginning of the next summer is only 40%. So looks like we are going to build a Markov chain model of a reservoir, very simple reservoir system with this example. Okay. Okay, and the problem description also provides you the state of the system for your Markov chain model, saying that state number 1 represents the condition full, and state number 2 represents the condition is not full, right? And in your handout, you don't have this, right? But you should be able to get this, right? By reading through the problem description. Because the state number 1 is full, and then state number 2 is not full, right? So it's full and not full, right? And then also here, these are the first passage probability, first visit probability, right? So this is F1, this is P1, right? And you know that these are always same, right? And then this is F squared, right? And so on. This is F cubed, F to the 4th power, F to the 5th power, right? So all of these informations are given. As well, this is, as a user, pi i's, right? So this is pi 1 and pi 2. Okay? Also, I provide you mean first passage time. So these are the M matrix, okay? And say these are M matrix. And this value is, for example, M12. This is M22, right? This is I'm sorry. What happened? This is M21. Of course, 1.5 is M11, right? So we're going to use all of this information to answer for this series of questions, A through F, right? Okay, so let's do this one by one. Okay, so let me make some space so that I could work on that later. Okay, so first we need to draw a Markov chain diagram, okay? Which is very easy, right? We just need to use one-step transition probability matrix or one-step first passage probability matrix. So let's say this is 1 and then 2, like this. This is 4 and not 4, right? And then 4 to 4 is 80%. And then 4 to not 4 is 1 minus 80%, which is 0.2. And then not 4 to not 4 is 60% of chance. 1 minus 0.6 should be 0.4. That is very simple, straightforward, right? Now, let's work on part B. We need to write down the equations that could be used to compute the steady state distribution. Okay? So basically we are going to use pi equals pi p in matrix form. Sum over pi's equal to 1, right? That's what you are going to do. So first, pi 1 should be pi times the first column of this P matrix, right? So it's got to be 0.8 times pi 1 plus 0.4 times pi 2, right? That's what I'm going to write down here. So here, 0.8 pi 1 plus 0.4 pi 2. Likewise, pi 2 equals pi times the second column of P matrix. So it's going to be 0.2 pi 1 plus 0.6 pi 2. Right? And you know these two equations are linearly dependent, so you need to take out one of them. Okay? Just you need to choose arbitrarily one of them and then discard it for the computation. So you can either choose this or this if you want. And then add pi 1 plus pi 2 equals 1. Okay? So in my case, I'm going to solve these two equations to determine steady state probability distribution. Okay? Of course, if you solve this linear system of equation, then you should be able to get this value. Okay? But I already provide you. Okay? So you have to make sure about this later. Okay, now let's move on to the question C. So over a 100-year period, how many summers can the reservoir be expected to be full? So which information you're going to use to answer this question? Pi 1? Okay, so how do you answer that? 0.667. But the thing is here, it's specifically mentioned that over a 100-year period. So you need to multiply, right? 100-year times pi 1. Okay? That's what you need to do. So what is the value of pi 1? Is 0.667, right? So it's going to be about 66.7 years. That's what I would answer to this question. Does that make sense? Because pi is the steady state probability, right? We assume that after a long period of time, the state of system becomes stable, and when you check the status of the reservoir, about 66.7% of chances your reservoir is full. Okay? So, because it's been asking over 100-year period, how many summers can the reservoir be expected to be full? So that's why you need to multiply by 100 years. Okay? Then you will come up with about 66.7 years, 7 summers, I have to say. Okay? The reservoir will be expected to be full. Okay, then how we could deal with next question. If the reservoir was not full at the beginning of summer 2017, what is the probability that it will be full at the beginning of summer 2020 and it will be full at the beginning of summer 2022? So let's deal with the first question. So which information you're going to use? P21.
And for
So for here,
4 years.
you're going to use P21. Is that all?
And the multiple number of
Cube,
years.
right?
Yeah.
Because there are 3 years difference between 2017, from 2017 to 2020, right? So you have to use P cube matrix, right? And then specifically, the reservoir was not full at the beginning of 2017, so you need to start with subscript number 2, right? And then it will be end up with 4 after 3 years. So second subscript should be 1, right? So what is the corresponding number? P21 from cube.
0.624.
So that's going to be 0.624, right? Down here. So this is 62.4%. Is that right? Okay. Similarly, how do you answer this question? Second one? Right now, we need to use P to the 5th power matrix, right? And then same subscript. Okay. What is this? It's going to be 0.65984, right? Is that very easy, right? So here, 0.65984. 65984? No, it's not. Here, 65984. Is that right? Okay. Which is about 66%. Okay. Okay. Any questions so far? Okay. Now let's deal with question E. So it says, if the reservoir was not full at the beginning of summer 2017, what is the expected number of summers during the next 5 years that the reservoir will be full? So how do you answer this question? Yes, somehow we need to deal with that, right? Okay, let me put more space because I'm going to write something down here. So actually in this case, it will be easy if you define random variable, let's say G sub 5 is equal to 1. And I would say if the reservoir is full, okay, for the next 5 years. And we are starting from not 4, okay? Not 4 this year. Okay? And then, of course, G sub 5 will take the value of 0 otherwise. Okay? So we're going to define this 0, 1 binary integer variable. Okay? Then next thing is how to get the expected value of G5. How do you get the expected value of this? Let me put more space. So how do you get the expected value? 1 times
value 1 plus sigma
P sub 2, 1, right? Starting from not 4, and then it will going to be 4 next year, right? Plus what? P sub 2, 1 square. What is this? Starting from not 4, it will going to be 4, 2 years from now on, right? Plus P sub 2, 1 cube. Continue on that. P sub 2, 1 fourth power. P sub 2, 1 fifth power. Okay? And then 0 times 1 minus all of this, right? Does that make sense? Is that right? That's how you can get the expected value of this variable G sub 5. Is that right? Okay. So let me rewrite down this equation. So it's going to be 1 times, if I use summation, it's going to be n goes from 1 to 5. Okay? P sub 2, 1 to nth power. Plus 0 times 1 minus this. Okay? Sum over n goes from 1 to 5. P sub 2, 1 fifth power. Sorry, it's nth power. Okay? Is that correct? And you know, this part is 0, right? Because it's multiplied by 0. So this is end up with just this. Summation n goes from 1 to 5. P sub 2, 1 to nth power. Okay? So that's the expected value of this new variable. Does that make sense? Okay? Now, let's go back to the original question here. It's been asking you if the reservoir was not full at the beginning of summer 2017, what is the expected number of summers during the next 5 years that the reservoir will be full? So actually, we already answered it, right? Which is this. Does that make sense? And you know, I already provide this information. If you go up all the way, right here. Okay? That is being said, expected number of visits during the first 5 stages. So, what is this? This matrix gives you the information of summation and goes from 1 to 5. P sub ij nth power. Okay? And what you need is this, right? Subscript has to be 2 to 1, starting from 2 and end up with 1. So what is that value? Go from 2 to 1. So it's got to be 2.89344. Okay? So it's going to be 2.89344. Is that right? Does that make sense? Okay, so although I provide most of this information, you have to understand each of this. Okay? Unless otherwise, you'll get lost. Because there are too many different numbers, right? So obviously, you need to understand what this P matrix are, and what this F matrix are, and what this is. Okay? And also steady state probabilities and mean first passage times. Okay? That's we already talked about earlier. Okay? Now let's go to the last question of this example. Okay, they ask you if the reservoir was not full at the beginning of summer 2017, what is the expected number of years before the reservoir will be full at the beginning of the summer? So which information we have to use for this? So it's saying that starting from reservoir was not full, right? And it's ask you expected number of transitions, expected number of years before the reservoir will be full. So what information you're going to use? By definition, you're going to use mean first passage time, right?
That's one.
Which is M matrix, right? And starting from not full. And then reservoir will be full. What is this? Here, 2.5 is what you need. Okay? This is 2.5. Does it make sense? Okay? I'm going to give you this type of example exercise problems maybe this week and probably next week as well. Okay? So we're going to have plenty of time to practice. Okay? And actually, I have some exercise problem sets. These are very easy to do. Okay? And you're going to notice that the last two problems are about the same as what I've done last time. Let me pull out this example. Okay. I'm going to post all of these problem sets on our class Canvas website later today. And do you need a solution for this? It's very easy to do. You know, it's just 2 by 2 matrix, and you just need to draw a transition diagram and compute p square and p cube matrix. And also, you can solve the linear system of equation to determine steady state probabilities. And just answer a very simple question here. And second, that here I just changed the numerical value, and otherwise it's about the same as we've done last time. All City Insurance Company example problem. And last time I gave you 2 different approaches, right? Depending upon how you define the state of system. So first one goes by 4 different state of system. And then second approach here goes with 2 different state of system. So you're going to see that is about the same as what you've done before. Okay? So, yeah, I can post the solution if you guys need. So let me know. Although it's a little bit early, but I'm going to stop here for today. But I'm going to stay here for a while. So if you have some questions, then I will try to answer for that. Okay? But our recording will be done right now. Okay? Thank you, Raman.